Well, thank you very much for having me here, and thanks to Joe for the invitation. So, what I want to start off with a little bit here is by turning this on. Can you hear me now? Is this a relationship of these two men up here? So we're looking at Sir Edmund Hillary and Tenzing Norgay, and this is the example of exploration. First two people recorded technically to have summited Mount Everest. And I'm not going to do very much reading here today, but I will do small amounts. And this is basically a relationship between that of a comparison of the architect to that of an explorer. And that the architect is not so different from the traditional images of an explorer setting out to discover new geographic territories never before documented and experienced. For the explorer, it might require traveling great distances, heights or depths to physically place themselves somewhere that previously may have been only observed from very far away, outer space, or predicted to exist from technological conjecture, ocean depths or remote territories. In doing so, new human perspective and knowledge is created, changing our relationship to both the new location as well as our initial presumptions of the places we left before our exploration. These explorations are as much a reorientation regarding our starting point as they are a discovery of the new places that only a few may experience themselves. The architect operating within a similar framework, but unlike the explorer, they don't need to travel great distances to see landscapes shift underneath their feet. The architect does this by standing still, pushing that environment prematurely into time, altering its physical makeup and advancing it into the future so as to ask of it something with qualities and conditions not seen there before. Recognizing the elastic nature of the environment around us, the architect does not physically explore to find scientific truths or define territorial certainties, but induce the potential futures layered within the same environment that others would assume to already know. So this idea of an explorer is essentially the fact that as architects, we are reinventing the environment every time we do a project. Whether it's a building, whether it's a landscape, we're essentially pushing that environment, that little geographic locale, into the future by making something there that wasn't there prior. But the question then becomes is, as explorers within this analogy, not to take it too far, the question is, how far are we pushing that idea? How far are we going out in terms of that exploration? Are we refining knowledge in places we've already been? Or are we seeking to go and create new territories that maybe generations ago were only figments of the imagination? Okay, I thought that was going to be the only slide for the night. And I don't want to dwell too much on this idea of science fiction, but there is an interesting correlation for me between the relationship of science fiction within architecture. And this is a conference particularly, and an article that was written by Neil Stephenson, who some of you may know. He's a science fiction writer. He's done books, Quicksilver, the Baroque Cycles, really interesting stuff. And this was a conference in which he was coming together with a bunch of other people, some scientists, some engineers, some politicians. And the point behind it was to actually start talking about the future. And it was called, actually, the conference itself was called Future Tense. Good name. And but there are two particular things that were really intriguing about the conference and within science fiction itself. And that is that the relationship between the audience, whether it's architecture or science fiction, and the other is the professional structure, which doesn't sound obvious at first, but I'll get into in a minute. But for Neil Stephenson, this idea of science fiction writer about these things, there are two things that are particularly intriguing about science fiction and what it does for science and engineering, and its relationship to those two. And he calls one of them inspiration theory, meaning that science fiction inspires people to choose science and engineering as careers. That good science fiction supplies a plausible and fully thought out picture of an alternate reality in which some sort of compelling innovation has taken place. And a good science fiction universe has a coherence and internal logic that makes sense to the scientists and engineers alike, and I would argue also a believability to the general public that's reading it. There's a second part that is really intriguing in terms of science fiction and architecture, is that when you look at the engineers and the scientists that are working and looking to be inspired by the tales in science fiction, you're looking at two disciplines that are getting increasingly more specific, right? So the world is getting more complicated, the sciences are getting more complicated, the knowledge is becoming more intense. So there are plenty of examples in which large engineering offices, science labs that have hundreds if not thousands of people who may spend their entire career working on one small bit of information as a contribution to the larger picture. So it's a kind of narrowing of the sciences and the specialties in order to deliver this knowledge. And in many ways, this is something that is happening within architecture. So think prior to the 17th century, in which the architect and the builder, the engineer, were all one in many regards. You could make the argument, obviously, that the builder and the architect were somewhat different, but the idea of the architect as an all-encompassing entity was there. Come into the 18th century, and there's that monumental moment in which architecture and engineering is seen to split as two separate disciplines. If you continue that forward, we're aware of landscape architecture as a profession, but technically speaking, speaking as a landscape architect as well, that's a profession that was sort of brought into existence in the 19th century. This continues on forward. So think within our own lives today how complex architecture is and how much effort and specialty needs to go into delivering an architecture. Whether it's now engineering is mechanical, electrical, architecture is structural. You have architects who work nothing more than just focusing on facade construction. You have people whose offices are based on information management. Just the fact that to produce an architectural project, you need to have someone who just manages the information correlation between those people and those entities. So it's a continually growing and intricate part within the profession. So the question, and I'm bringing this back within science fiction in the same idea, is that where do we kind of locate ourselves and our interests? So pick an interest that you're kind of interested, that you are kind of running through within your own practice or within a studio. The question is, do you see that as being yet another narrow field within the growing list of architecture? Or instead, do we see ourselves as stepping out beyond that and as a kind of encompassing agent that paints the picture in the future for what architecture can be, closer to that of a science fiction writer? It's not intended, this analogy isn't intended to be a complete tight fit in which somehow architect is the science fiction writer or it's the engineer, but it's not. It's obviously somewhere in between the two, but that correlation becomes a rather intriguing one. And what came about from this, which was equally interesting, is that there tends to be this idea within architecture that I think is also linked within science fiction, that is, as we start coming up with these ideas and intentions, our first response is to think whether or not how that is going to be received by someone who has more knowledge about that entity. What is the electrical engineer going to think? What is the mechanical engineer or the structural engineer going to think? How is it going to be received by someone who has a body of knowledge that can inform that work? And this is no different within science fiction. So when Neil Stephenson was at this conference talking about his lament of the end of the space program, wanting the future that was, speculated on when he saw spaceflight the first time in the 60s, where the big thoughts where the big projects were going to be within science. Where are the big moves happening in engineering? And he was surprised to hear from the president, University of Arizona State University, who was on the panel with him, to actually reply to him, "You're the ones who've been slacking off." So he's actually turning it right back onto the science fiction writer, saying, you're the ones who've been slacking off, that the engineers and scientists are waiting for those visions to fulfill, and that what you need to do is actually paint those pictures. So it's exact opposite of what he thought he was going to get. He thought he was going to sit there and actually have to push for a future that others were going to push back on. But but in truth, he got the president of the university saying, no, it's on your onus. You guys are the ones who need to be painting these things so that you can inspire that generation moving forward. So this is the case in many things. And again, this is not anything unique to architecture. I would say, in many regards, this is what architects do best, is that we paint those pictures, those environments, and those aspects of life that make people want to covet that. You know, that people want those conditions, whether it's the buildings that we pitch, whether it's the environments we paint. But what I'm trying to talk about for today, specifically, is that of energy. And I would say within energy, the architect has not taken that role. So here's an example of the 1939 World's Fair. So this is obviously prior to World War II. This is prior to the GI Bill. This is prior to the kind of break that we've seen with the sort of influx of suburbia that happened around that time. This is 1939 World Pavilion in New York. And this is a pavilion that was actually funded in 1939's World Fair called Futurama by General Motors, is who put this together. Exhibiting a projected future complete with models of suburbs, motorways, clover leaves, overpass, a comprehensive new reality brought people out of the cities and into the surrounding landscapes by paving roadways and petroleum-based asphalt on which oil-fueled cars could travel. It produced images of a lifestyle and an experience that were coveted by those who viewed the world in front of them, and pushed the industry of the automotive and the fuel to deliver it. So, quite honestly, you know, these are the pictures that were generated. It was a whole huge exhibition, but the point behind it was that what this created was a world that people wanted to be a part of. The people that the general public wanted to have. They saw the benefits of it. The pictures were laid out for them. And this became something that people strived for, that was delivered to them. The answers weren't all within the 39 Pavilion, but the big idea was there. And by moving that forward, the technology, the infrastructure was laid out to deliver this. When it comes to energy, though, we don't have that same vision right now. So if I was to say to you, to point to me within architecture, where you see innovation in architecture right now, and as it relates to energy, I think we'd be all hard-pressed not to point to the devices and the technology conditions. You would point to the energy-efficient mechanical systems. You would point to the HVAC system. You would point to the solar power. You'd point to wind power. You would point essentially to the technologies that we're refining and we're reworking that are pushing this forward and allowing us to get this energy. But we don't generally point to the new visions of what that energy can do. When the energy is no longer thought of as a fuel, but is thought as a material that actually can build the worlds around us. So, just as an example here, New World Farming, I don't know if anyone has seen the Hitchhiker's Guide to the Galaxy. The greatest challenges facing architecture and our broader society today is the need for advancements in harnessing energy. Rather than continue to focus on maximizing efficiency in its conservation and consumption, we must provide an architecture with lifestyles for the future that give us new worlds to strive for and realize. Without this fundamental rethinking between architecture and energy, both will remain seen as discrete. Architecture as a building of walls and energy as the fuel for filling it. Instead, architecture is in a unique and advantageous stage for questioning and reforming our definitions of architecture and the environments and lifestyles they foster. Harnessing will always be a part of this equation. In the near future, it will only be a portion of the equation, though, as energy becomes a material that subsumes both the spatial and organizational responsibilities that we lay upon architecture's current building masses that include the aesthetic as well as social dynamics. The act of its release, how we shape it, this energy, and the architectural roles we entrust to it as physical material will move it to the foreground. This shift in action will turn energy from a resource into a material, and therefore into an architecture, a building block for constructing space and defining social organizations. So, to give you an idea of what I'm talking about here, these are two ways in which I think we see architecture potentially. On the top is architecture as mediation. So for the most part, when we think about architecture, we think of architecture as that pink line, meaning it's the thing, it's a surface, it's a geometry that we choose, we construct, and it decides what our relationship is to the environment. It either lets the environment in through breezes, through porches. It either reflects it back out, or it absorbs it. And architecture is that mediating device that does all the control. So when you think about the geometry, that's essentially what's defining that space. So in a room right now, right, we have walls, the ceiling, the floor. These are each components that define this space. And it's that purple, that pink line, that's the architecture. The question is, can we actually start designing and using those white lines, which are those energies that move and course around us daily, as an architecture? Can we think about the form of energy through electromagnetism, through thermal dynamics, through acoustics, and through chemical compositions, and actually heighten those to become an architecture? And we know we can do it, and I'll talk in more detail. Everything between the advancements in software computation, CFD, computational fluid dynamics, we can visualize energy like we've never been able to before. Obviously we can control it. We create internal climates throughout the world homogeneously, no matter where you are. So we know we can control the energy. We know we can visualize it. The question is, why can't architecture be that energy and not rely on the geometry that holds it in? So to give you two examples of just how ingrained this is. These are two examples. One I call the stacked duck, and the other one's the stuffed pig. Just to kind of highlight the fact that as geometry and surfaces, these are our primary means of organizing space as architects. Our basic move as an architect is to create a boundary. Robin Evans talks about this, right? That at the most basic move, architects decide how to, through boundaries, separate an activity from each other, and then decide how that activity comes back in contact with it, right? Whether it's a corridor, a door, a wall, a glass partition. And we do that with lines and surfaces. Whether you're drawing, sketching in your pad right now, whether you're working in Rhino, Maya, CATIA, Revit, Illustrator, you're drawing a line, and that line represents a boundary, and that boundary becomes a wall, and that becomes architecture. And right now, we generally, when we think about that, we come up with two basic camps within architecture about using the line. Whether it's the idea of coming up with programs, an entrance, a theater, what have you. We break them down, we make foam boxes out of them. They become programmed, they're discrete objects. We understand their requirements and their parameters, and then we stack them together to then create an image that you recognize as a building shape, right? Pixelated, fragmented, I don't need to call out what that is. Or the flip side of it is the stuffed pig, more like a butcher's block, in the sense that the outside geometry and intricacies of that line are predefined. That's the intentionality. If this starts as an internal logic of program and action, this you could say comes from an interest in the outer form of the project already. When that's done, you chop it up like meat and you say what things are. It's not a great theater, but it works as a theater. There's your courtyard, your mechanical system, your core, your entrance. So nonetheless, it's two ways of thinking about space, but nonetheless, as different as we make them appear to be within the discipline of architecture, they're much more similar to each other than we think. And that's because they work by using surfaces as our way of organizing space. Now, this idea of using energy is a lot less far-fetched than you may assume. This is going on every day within your existence, right? So whether or not you build a building that casts shadows, creates reflections, the infrastructure on your campus or within the building that has excess energy that gets dumped into the landscape. This is every city street that has a grate that's showing up, that's producing steam in a winter night. Energy dumps, You had Michelle Addington here in the spring who talked about this. The way of using excess energy, buildings are always going to be, to a certain degree, some form of inefficiency. And when that inefficiency is dumped, it makes its way out through exhaust in the buildings and into the environment. Or the most obvious, largest urban scale one is the idea of the urban heat island. So the most extreme versions of that would be Houston or Atlanta, where so much of the city has been paved, both through the roads and infrastructure as well as the roofing systems, that the temperature of that city changes because of all that pull of the energy that's being absorbed in that material. So you're actually changing microclimates. We're designing microclimates every day with our buildings and structures. The problem is we just don't do it as intentionally designed moves. They're byproducts. They're things we do unintentionally. The question is, can we take that and do that as a design initiative? Can that be something we start off with as our goals and orientations? So just to put this in a little bit of context, architects, I'm talking about energy now as a materiality and questioning what the role of that materiality be, why we're looking at that materiality, and what some of the implications could be. So, and this is nothing new in architecture. We've done this through glass, through the advent of iron and steel, concrete, giving us a transparency. This is a Richard Neutra house in which the inside and the outside quite literally blurs together between the two. It's not actually blurred. I mean, there's a physical boundary there between the two. Or the idea of steel spans and cantilevers that have given us cantilever construction, larger interior spaces than before. Or the idea of concrete malleability. Each one of these aren't neutral materials. When a material is used and exploited within architecture, it usually produces over time new typologies. It produces the ability that when iron came about and large panes of glass, we got the great exhibition halls of France and England. We got greenhouses for exotic plants and animals that we were collecting from around the world. The point is, when a material can be exploited to its full potential, it isn't a neutral vehicle. It isn't just reproducing something we already know. It's giving us new opportunities, both within our programs, our actions, our social interactions, and the architectural aesthetics of themselves. And this is really nothing, again, you can trace this in a sense within architecture. So the interest in energy and air, in a way, has always run parallel with maybe more of the masses that we think about, the surfaces, the kind of ossified energy as a block. So whether you're looking at Borromini's Quattro Fontana in Rome, this interest in the plasticity, meaning asking stone, asking stucco to create a kind of plasticity that maybe isn't inherent within the material itself. Roughly within the same time, this is 1638, within around the same time period, Jean-Baptiste Helmont uses the word gas for the first time to define a state of matter that's not solid and not liquid. Lightness, Ecstasy of St. Teresa, this interest in actually from Bernini blurring together St. Teresa on a cloud you can't see very well. She's on a stone cloud. It looks light. It's hovering off the ground. You have a light source that's coming from outside that no one can see, that's making this whole thing glow. You're working with heavy materials and trying to make a lightness from it that isn't inherent in the material. It's a desire, it's a need, it's a want, but it can't be produced. But around the same time, almost to the year, atmosphere has weight. It's confirmed that a theory that atmosphere has weight by carrying a barometer to the top of a mountain to show that atmosphere pressure decreases with height. Or even this idea of synthetic interiors, the fact that synthesizing oxygen, nearly 70 years prior to the cast iron glass frame public exhibitions of structures that would emerge in England and France for reproducing exotic climates and expansive interiors of vegetation from distant lands, Carl Scheels synthesizes oxygen for the first time. So the point isn't that architects and in the sciences aren't interested in the same things. It's just been a lag up to now. And one of the most intriguing examples comes from World War I. And this is something that Peter Sloterdijk talks about, which was the advent of gas warfare. And I'm bringing it up because it's an intriguing moment in time where this is an example he points back that says for the first time in war, you have a moment where people aren't actually targeting the body with projectiles. You're not shooting arrows, you're not shooting bullets, rockets, you're not trying to harm the body by actually destroying it. Instead, you destroy the environment, and that kills off the inhabitant. So this idea of chlorine gas introduced onto the fields in France and Belgium, that actually by dropping these vials and the wind comes through, it creates these large interiors within the landscape. If you're the inside of that thing, you were affected by it and you were killed. If you're on the perimeter of it, you receive effects from the condition, and if you're on the outside of it, you didn't get anything. So there's actually boundaries now being produced by this chemical warfare that affects the body in different ways. Of course, the most obvious thing to do in that example is the idea of the gas mask, right? You produce something that can mediate the body from the surrounding. You find a way in which the body's senses can occupy a poisoned environment and not have the experiences, obviously, that it's associated with the death. The reason this becomes interesting is because I'm making the correlation that as ghastly as this is, this idea of manipulating the environmental materials, the gas, the air, as a materiality for attacking the body as opposed to an object, that architecture took more cues from this idea of the gas mask as a mediating device than from the chemical warfare itself. So this is quite illustrated in the idea of where air conditioning comes from, right? So we're familiar with air conditioning now as a cooling system that we have in domestic homes, as units, as large infrastructural systems in buildings. But when air conditioning started off in the late 19th century, its interest wasn't so much cooling, it was actually removing moisture from the air. It was dehumidifying. And it was so that factories like this wouldn't have down days. So if you had a factory working with cotton or chocolate or what have you, if the outdoor environment was getting in the way, the humidity or the heat, you would have to shut down production. The thing that came about this was that as these systems were put together to actually pull the moisture out of the air, a relationship occurred between the owners, the workers, and the architect, or the engineer at this point. Because the engineer was specifying that they wanted this at a certain humidity level for production. The worker wanted a certain comfort zone, and the owner wanted an efficiency, right? So you had these three going on. So if you're going to work with producing and telling somebody that I can work with your factory and give you a certain relative humidity, the first thing you're going to want to do is make sure that they don't have any external forces working on it, right? So you're going to lock down the factory. And this is where the kind of hermetic sealed interior really makes its position felt within architecture, which isn't very far from this idea of mediating the environment to the extreme, right? So the one thing I didn't have in that example earlier on was the idea of mediating, which was letting something in, bouncing something off, or absorbing it, was now sealing that hole completely to the point where you just conditioned through an artificial mechanical system an interior. Now, to jump to this a little bit is this idea of actually designing that environment. So what if we're talking about getting rid of this idea of using geometry and walls as our primary means, not the fact that it can't be involved in the conversation at all, but not our sole means of organization. And one of the most intriguing parts that comes from this, as in a kind of an analogy, oddly enough, it comes from the 2008 Olympics. So as architects, we think back to the Olympics. You would have put an image in your mind of what the Olympics meant to you. It's likely that you're thinking about images of Herzog and de Meuron's bird nest. You may be thinking of the Beijing National Aquatic Center that looked like water droplets along the facade. Essentially, our images as architects and as a general public of the Olympics were these large facade constructions. But as we know, thinking back upon the Olympics, the environment that the Olympics were taking place on was a huge conversation, right? So days leading up to the actual Olympics, they had removed or stopped allowing the use of cars and vehicles to actually bring down the pollution level for the inhabitants and the athletes using the sports centers. And this is also known quite often, obviously, in running, where many athletes regardless of the sport, will actually work at higher altitudes with less oxygen as a way of increasing their fitness level. So when they come down to the ocean level, there's more oxygen and their performance increases. So we know that the environment that you're working in actually increases and plays a role in your performance as an athlete. But when we go back to swimming and we think about the pool, we generally have an image of the shape of this pool, the kind of blue outline conditioning. And there was a conversation that was going on with one of the former Olympic swimmers during this time who was a broadcaster, and they were talking about what was going to happen with the pools in the future. How are they going to get faster? Because at the end of the day, within any sports, is you want faster times, and you want to break records, and you want more viewers. And what he was talking about was that the general consensus was that this pool was as fast as it was going to get. That through a series of methods within the geometries here, they could make what they called a faster pool. So that meant that the gutters, there was a technology within the gutters as to how far off they were, that as the bodies was swimming through the water, it would dissipate and lock into the gutters. There was a depth within the pool, so that as the body was moving through it, those waves wouldn't come back and retard the movement of the swimmer. There are things that we're all familiar with, the wave eaters, so that as these two bodies are moving through the water, they're not actually interrupting each other. But all this was being done through the geometry of the pool. And at that point, he was saying, what was really intriguing was that the pool, as it comes to how we sculpt that space, had reached its kind of apex. And beyond that, when we think about swimming, most people during the Olympics, 2008, if you've watched it in 2012, you probably saw only this, meaning a swimsuit from the waist down to the feet. Because at this point, in 2008, you had these swimsuits that were a complete body, and sometimes you had examples of people wearing more than one, just as a way of building air pockets in here so you could move through the water with more buoyancy. I think there was something like 50 world records broken in swimming alone. One race in which the first 5 people who finished were all under the world record. And many, even in the 2012 Olympics, have acknowledged that their times will never be met again. Like they'll never get that time again. It's because it's been decided that you can't wear these suits anymore, that you can only wear these. So there the conundrum was that, what are we going to do in terms of an equal playing field? And what the broadcaster came up that was really rather intriguing was saying, if the pools are going to get faster, and we're continuing to break world records, obviously the athletes are going to get better, but it's not going to come from shaping the pool, it's going to come from changing the chemical composition of the water. It's going to come from actually changing the salinity of the water, chemical compounds, so that it's an equal playing field in which the body moves through for each athlete, but it will increase and make the pool faster, which has always been the interest, right? To try to get that as fast as it could, but saying that the geometry had done its job, and now it was going to be the chemical composition that the body moved through. And that this was going to be the new frontier, one in which the space that the actually athletes were working in. And I'm just trying to make a distinction here. This is a beautiful project by Peter Liversidge. But it's important that what I'm mentioning here is that I'm not talking about reproducing recognizable weather. When I talk about energy and I'm talking about these microclimates, I'm not talking about taking something that we know to exist, like a beautiful day in San Diego, and reproduce it in Vancouver or Chicago. That's not the idea. And to kind of push that analogy a little further, it would be like saying, we all know that there is a geology that we all pull from for our building materials of construction, right? Whether it's concrete, steel, glass, whether it's reinforced concrete in terms of the aggregates, the reinforced steel. We take the geology that works around us and we produce a new architecture. We don't reproduce caves, right? We take all that geology and we refine it, we meld it, we come up with new chemical reactions to smelt iron, to then create steel. And from that we create St. Peter's, we create the great works of architecture that have come from that. But they're not a reproduction of a cave. And the same thing goes for microclimates. When we're talking about energy. The intention isn't to then reproduce what we know. The intention is to take that as a material and advance it to create an architecture all in itself. And the reasoning behind why we do this, or why the interest here, is that we know that when we fiddle around with that material that we use for organizing space, that there are large repercussions that come from it. So this is from Robin Evans again, who talks about these first two, the necklace circulation and corridors and destinations, saying that when you look at a 9-square grid, a Palladian villa, versus something you've probably walked through today, that in a necklace circulation, you move from one room to the next room to get to the space you do. And as you do that, you come in contact with other people in other rooms. And that had a social implication that was also tied to what people thought about what an interior was. This was also an issue in terms of society. It wasn't just a move of the architect. But there was a relationship between how people moved and how people came in contact with each other, and how that affected social interaction, as well as aesthetics of the architecture. And Robin Evans goes back and says that he can pinpoint roughly in England, more or less within the 17th century, where he finds the advent of this idea of the corridor. I mean, we think of these typologies as being omnipresent and that they've been with us forever. But in truth, he says that through the advent of the corridor, you no longer have people walking through spaces anymore to get to the next. People get off an elevator or come upstairs and they go right to their destination. It becomes this kind of hermetic relationship. So just by taking something that is a surface and a geometry and starting to play with the characteristics of it, you get a very different relationship that is not just about swapping of one material for another. It's actually a different typology. And what I'm laying down here is just the basic idea that not knowing what all the implications are yet, but realizing that if you start working with energy, which can't be represented as a line, it's more of a behavior, it's an exchange of information and energy. Energy works as a gradient, right? So whether you're talking about sound waves, thermodynamics, heat, light, they all work essentially as a gradient condition. And the idea then is, if we move from this idea of lines to geometries to that of a gradient, what then are the repercussions of how we move, how we circulate, how we come in contact with each other, and how we come together? And these are no small questions, but we do know that at such a fundamental level, if we can move from this to this, that there will be those repercussions. So just to kind of give a couple of examples of some design work, before talking in more detail a little bit about what a material energy is, or what an energy condition is, this is a project for the Tumula lakeside planning. And the idea behind this was, as you can see, it's roughly 11 hectares, with the lake here, the existing town down here, and they were trying to find a way in which they could integrate within this existing lakefront area residential, commercial, and a hotel to kind of stimulate the growth of the town. So here it is. Here it is here. What we wound up doing is, when we were looking at this, and this comes a little bit for why I was originally supposed to be in Rome, was this idea. We cut a basic plan through the site. And when we were doing it, we just made it black and white. And realized that what we had here was essentially a Noli plan. So a Noli plan was a drawing of Rome for the first time, in which they cut all through Rome in one large drawing that was just black or white. And when it was black, it was private. And when it was white, it was public. And it gave you a whole new understanding of how Rome worked, because it allowed you to see pockets of interiors that were available for you as a public member that you didn't see otherwise. So it was a kind of it's the same city, but seen through a different lens. So all the churches, all the plazas, all these interiors would be represented as white, because it was publicly accessible. And when we did this, we realized that we essentially had a type of gradient, a type of Noli plan, except ours wasn't a public-private, it was conditioned and unconditioned. Either it was being heated and cooled, or it was the natural environment. And so every white piece you see here is a conditioned interior, and obviously it coincides with the boundary that outlined it. And everything that was black was supposedly open to the environment. So what we thought to do was actually create a gradient Noli, which was this idea of trying to find if we could work with energy to output it and condition the environment of these nodes for use as an infrastructure that would change throughout the course of the year. So you can see, and I'll talk in a second, this is winter, fall months, and summer. And you can see that the idea is that when we start talking about the shape of energy is that it's not consistent like geometry. It doesn't stay static. So in the summer months, production of energy and pushing it into the environment may give you a larger mass. As you get into the winter and it's cold and the environment pushes back, you still have the little microclimates being produced, but they're just not as large. So these, what we started looking at these were the activities that we mapped throughout the course of the year, realizing that these are what they wanted on the site. Some could exist throughout the year, and some actually had only small moments of time in which they were usable. And we created a large kind of plinth system for building interior, and then created this large greenhouse glass structure on the top. And the intention was to use that as a way of collecting energy that wouldn't be used just for the interior of the space, but actually be pumped down into the voids you can see on the right that would go into the landscape. And that this would then be a way of creating environments that could be used as generators for activity within the city. So every red box is a void within the large plinth that is then getting that energy pumped down and used as an artificial microclimate on the exterior of the building. So think of it as a really extreme street lighting. What street lighting did for parks in the city, this is doing with a larger spectrum of energy. Another example was a project in Iceland. So Reykjavik is up here. I keep using this mouse, but you guys can't see it. To the right and to the south. And what they're looking for, this is an old American airstrip during World War II. And they were going to turn this back into a redevelopment plan. So everything from a university to housing to shopping. The idea was to create a master plan for this area that could be used for the development of the city. And what we did, well, okay. What we looked at here was a way in which we could create an organizational structure that didn't rely on how you may originally see it. So thinking about, this is the image, you have a large axis. When we generally think about urban design, we think about either axis or resource points. So one initial move would have been to allow this to work as a large boulevard, a cross boulevard. That would be an organizational structure of roads or infrastructure that would give us a way of organizing the system. Instead, we found ways of organizing parking in the roads off the perimeter with large parking garages. We created mounds of earth on top of the parking garages, and then took something which we called the wash. And what the wash was, and you can't see it right here, but this is a pool on the bottom. And there are existing pools here, which you can't quite see. Within Iceland, which is really intriguing, is that nearly close to like high 90% of all homes within Iceland are heated by geothermal, right? It's a resource that they have within the makeup of the geology that they can harness and use. So by using geothermal, it's a way in which you can then heat the interior of the house. There's actually such an excess at times that unused energy that comes from the process gets dumped out. And it gets dumped out here in this brackish water. This is just one instance of it. So even though this is the open water here, which is extremely cold, this is a brackish water, meaning some of it is actually coming from that water and some of it is enclosed. That can actually pump that excess heat into that water and make it swimmable for parts of the year. So they're actually allowing that excess water, that the energy that's being used, dumping it out into the water and allowing people to then swim in that area. So what we did with this, with the wash, was to say, what if instead of thinking of it as an organizational device through streets and infrastructure, we instead take that excess energy and pump it into the soil. So we create a way in which that excess energy, instead of being put into the pools or being used solely for the interior of buildings, was to be run into the soil itself. And by doing that, we then build on top of the hillsides the cultural districts, the commercial, the housing and such. And the thing that ties it together and makes these links between them are the wash. And that wash, again, is not a static, is not a static condition, meaning at part of the year, in the winter, it may look more like this, meaning excess energy that's being pushed into the soil, allowing for vegetative growth, allowing for movement and circulation, people being able to be down in these valleys and move through those valleys as a circulation path or recreation, so on and so forth. But there is a context, and context in terms of energy isn't always about adjacency like we would think about a building or who's next door to you. Context when it comes to energy is climactic. So in the winter months when the winds change, these were wind diagram drawings, so the wind and the cold would actually cause that space to shrink. As the summertime comes, that heat and those conditions would actually expand and get larger. So you can actually see the size of these things shrink because as they increase in the summer times and the fall, you can actually increase those activities and they come up the sides of the hills. In the winter times, they're smaller, they're more discrete, they may be pocketed, but it actually changes throughout the course of the year. So within these hill systems, you have the recreational fields, you have the circulation, you have the buildings and the large systems on here, and then this becomes a public thoroughway that connects those two together. So what are those energies? So to give you just a kind of quick background upon this, when we talk about material energies, I'm talking about when energy becomes an actual building block, meaning the same way we think about steel, concrete, or iron, or glass, we build with them, and those take on the responsibilities of architecture. Responsibilities meaning they keep the wind out, they keep the rain out, they organize, they protect. They have a level of responsibility that's required of them to be qualified as architecture. They're not byproducts, they're not loose. They actually do the things that are necessary to call it architecture. But there's a long history when we talk about energy. And one of them is this idea of an aura, an effect. So quite often when we think about energy, we tend to think of it as, I would say, almost like an atmosphere. We think of it as a quality, an effect, a mood. It creates a condition. And Jeff Kipnis talks about this in The Cunning of Cosmetics, when he's talking about Herzog and Demeron's work. And he's talking about the kind of moods and effects, and the idea of a cosmetic, quite literally, is that you need a surface to then embellish with another thing. Without that surface, that thing goes away. You can't have, there's no good to have makeup if you don't have a face to put it on, right? So when he talks about Herzog and Demeron, he talks about all the kind of effects, and you get color, and you get mood, and you get the reflectivity. But quite often, without the thing that's doing the real work in all these examples is the plastic, it's the steel, it's the concrete. That's a portal, that's a way of moving in, that's a way of blocking something. So the geometry is doing all the work. The energy is simply an effect, a byproduct, and it's not architectural. The flip side of it is that we talked about the advent of air conditioning and dehumidification. That is almost the exact opposite side of it. It's the over-engineering of energy to the point where we come up with an advent where we come up with this idea that we all know. This is a chart from 1914 Carrier. It's not a coincidence that it comes from an air conditioning company. And this is how we define comfort, right? We have a sweet spot here that was decided and definitively controlled between air velocity, moisture, and temperature that we recognize as our comfort zone. And we control that in a kind of very specific way of reproducing something we know. So we're calling it comfort control because it's basically saying we do control light, we do control air movement, we do control heat, but it's generally to produce a predefined condition. Meaning it's so that your eyes are comfortable when you read, it's so that you're not too hot or too cold. But with this, what's intriguing is that we do quantify that energy in a way we don't do with an effect. What I'm trying to get at to is the next level, which is the material energy, which is the fact that it becomes a building block that takes on responsibility. And it defines a boundary. This requires you to have a geometry, a box to fill it in. Architecture is the box. Energy is something you fill it in. And in this case, street lighting is probably the most simple example that I can point to as a material energy. So that when you create a light, it creates a boundary. That's a boundary you can recognize. That's a boundary you can see and you can be in. When you're in that boundary, you have safety and you have control. When you're outside that boundary, it's darkness and you don't know what you have. But it's a true physical boundary that's being created. And that is not reproducing the sun. It's something completely different, right? It's thousands, it's millions of point lights throughout the world that create a wash that we see here. This one's more of a necklace condition where it's discrete pockets, others are continually flooded. But the point is, when material energy like lighting came about, it stimulated growth. It stimulated the city in new ways. It produced the ability to have recreation outside when the sun would set. It created safety in cities, and it created commerce, shopping, and facilitated that. So it's an example in which it has a typology. It can be understood as discrete or chained. It could reinforce the city that you know now, meaning the same road and same path you took in the park. At nighttime, it may be the same path. Or, due to lighting, it may be a different path. The point is, though, that that light, though it's the full spectrum, visible light, has a boundary that is considered what I would call architecture. So architecture at this point, when we look at material energies, we're looking at chemical, electromagnetic, thermal, sound waves, and these become building blocks for architects to work on. And when you move outside of that, you start thinking about comfort control, you start thinking about auras, and the further and further away you get from the architecture. So the same way we think about the kind of orders of architecture in the most kind of tongue-in-cheek way, the Greeks from the Doric to the Ionic to the Corinthian. This is an Yves Klein project called the fire column. And the question just is to say, like, can we take energy and put it along the kind of orders of architecture and make an architecture out of it that has its own, not only its own spatial boundaries, but its own aesthetics and visual connections that we would have to why we have Corinthians versus Ionic and Doric. How am I on time? So just a couple projects just to close out. This was a project in San Jose that we were shortlisted for. And the idea behind it was that it was a public project in which we were trying to create an outdoor microclimate in the vein of a tactile surface. So think about ground cover vegetation. When you have a nice day, there's grass out, it's well cut, the sun is out, the bloom is there. It's a great day to be outside and use the resources of the climate for what it is, right? But if the rain should come, the winds come, or the flowers don't bloom, this is not an intriguing place to be anymore. It's very subject to the weather. The flip side, think about ground cover like carpet. Your hardwood floors, we create these throw rugs that give the body the ability to become tactile. And what we were looking at was this idea of an extreme artificial ground cover, this idea of an exterior carpet, much like AstroTurf, right? So, and Blair can either back me up or tell me I'm completely wrong with the story, so let's see what happens. So with AstroTurf, I mean, it's called AstroTurf for a reason, down in Houston, the Astrodome, eighth wonder of the world. You have this large structure that is so large, it had a glass canopy with the field of natural grass below it. What's really amazing is that it was actually so large, and the temperature differentiation between the top and the bottom was so extreme that they actually started to create little microclimates and small weather conditions. It actually would be precipitation occurring inside the Astrodome because of the heat on the top, the coldness on the bottom, you get a convection cycle, and you get rain. So what they wound up doing was actually painting the ceiling and the glass black. And of course, solve that problem, but you don't have any grass growing anymore. So from that came the advent of AstroTurf. What AstroTurf allowed them to do was have a playing field that looked like grass, that performed like grass poorly at that point in time, but it was enough that they could play the field and have games. So what we were looking to do was to create an extreme version of AstroTurf, somewhere between AstroTurf and a throw rug for the outdoors that actually allowed some people to come together as a kind of installation and actually use these carpets for outdoor space. And the idea behind it was that through a combination of white noise, heating systems, and light, we could actually create these small microclimates within an existing landscape that people could come to and rest on and lay on and actually get these conditions. So if it was outside past a large road, through white noise and feedback, we could actually drown that out. You'd have a little microcosm of sound controlled environment. These are aluminum plastics that had a current running through them that gave off a small amount of heat. Each one was rather discrete and small, but collectively it created a gradient of warmth. And then this was much more tactile. But the idea behind it was, could we actually start changing and augmenting that local climate, both through the tactility of the ergonomics of the body, but also by creating these large rugs that in themselves had subsets, right? So even though this rug was large here, you had different zones for different activation and different control. So they were unique from one to the next. Another version of that was a project called Wanderings, which looked the exact reverse of that, the inverse, which is creating a seating system that would actually allow you to change the temperature, both to your body and the environment around you. So what we were looking at, again, which was similar to the project in Reykjavik, was to get a rough understanding and say, these are some general activities that happen throughout the course of the day in Chicago. And in Chicago, which is rather intriguing, is that the park systems are hugely important. And in the summertime, they are extremely well used. From concerts to events, every weekend the parks in Chicago are full. But as soon as the winter comes about, they drop because people can't use them. So the analogy you're making is similar to street lighting. What street lighting did for park systems, when street lighting came about, the park was usable when the sun set. And our question was, could we actually create little microclimates that would allow the park to be used in the wintertime, even though the snow or the cold had set in other ways? So we wound up doing, okay, I'll skip all the line drawings. All right, so these are some just initial prototypes that we did where we milled out the kind of basic framework. And this is essentially PETG, which is what your water bottles are made out of. So it's a recyclable plastic that can be vacuum formed over the large shells to create a kind of plastic mold. And we threaded those together. And we wound up doing was creating these seating systems that were sealed cavities. So imagine a sealed cavity that then has a heating filament inside it. The idea is that you trap that air and then you heat that air and it becomes warm. By doing that, the body could then sit on these things and actually become tactilely warm through conduction, but also the temperature of that individual piece would affect the kind of local microclimate around it. The drawing here that you can't see was essentially showing each of these as discrete objects that in themselves didn't produce a lot of heat, but when they started to collect and nest together, they started to create larger environments. So that same piece that's like that you see here, this is what you visually can see, but this is actually physically what's happening beyond the spectrum of the human eye, right? So let's think back to the idea of the infrastructure dump we talked about, where energy from the city is dumped into the landscape. You can't see a thermal condition. We don't have, the ability to see that with our eyes. But when you do pass a patchy green grass in the middle of winter, you know there's a heat source coming from somewhere that's dumping into that landscape. So the question is, how could we continue to work with this so that we created a resource and an infrastructure, and essentially a climate infrastructure for the city of Chicago and the parks that could be used as a resource? And one last piece here. This is a later, most recent project called Serenus, which is named after, well, I'll get to that later. The sirens from Homer that called people to their places before they were destroyed as little kind of calls within the kind of landscape of the sea that brought the sailors to these little islands. The idea behind this was that in the city of Chicago, in the park system again, Serenus was the name of the island of those calls. And the idea here is that these become little refuges of microclimates that would exist in the park. So the same way that we had this trapped heat cavity here that was giving off heat from a heating filament that was embedded within it, this was a much larger scale. So you can almost imagine the AstroTurf, extreme AstroTurf, that shag carpet, and the Wanderings project as a kind of bigger amalgamation, in which this is a large hill that has a trapped heat cavity within it. It could come from the infrastructure of the city. It could come from a renewable source outside. But the point is that that energy is being built inside here so that these individuals have a tactility against it. And that excess energy is then being dumped and pushed into systems below here where there's just basic seating and chairs. And the idea is that you tend to start to create these microclimates of an architecture that have boundaries and have discrete control where you can tell when you're not inside the production and when you are. So the idea behind this is that these are all clear 3D printed people, and the ones that are clear and transparent are people who are not in the system, and the people that actually have a color and tinge to them are people that are actually involved in being felt by the system. So one of the big issues that comes up when you're talking about energy is how do you recognize boundary? Boundary generally is something that is visually seen. Meaning you can actually see that, you come in contact with it, and it's in the visual spectrum. With energy, you're talking about a lot of energy systems that actually aren't visible to the human eye. So you have to find other ways in which that is represented or quantified. And one of the things I'm not going to get into today is the idea of the human body and the advancements of the human body, but that's for another day. But these 4 kind of points I'll just read through quickly are what are kind of the generalization for what is going on here. So the greatest challenge facing both architecture and our broader society today is the need for advancements in harnessing energy. Rather than continue to focus on maximizing efficiency for energy's conservation and consumption, architects must provide a glimpse into the potential futures we face, related to lifestyle and art, that give us new worlds to experience, strive for, and realize. Architecture will transcend its predominant method of constructing physical boundaries with solid-state elements and instead define space with a gradient boundary inherent to energy. Energy will be seen as a building block material to carry loads, define spatial hierarchies and circulation, and provide security, create aesthetic malleability. The result will be an architecture of intensities unique to the spatial and organizational implications of energy. Third, chemical performance enhancers, implants, surgeries have artificially altered the human body's physiology and sensory perception. These alterations permit us to perceive a range of material energies and potential systems of organization that were previously unperceptible. At the intersection of these 2 seemingly distinct areas of research, increased sensory sensitivity and the architect's control over the new range of material energies, lies the potential for a new architecture. And without getting into this is just basically saying that what's really intriguing that are happening 2 separately within the discipline. So we're talking about, going back to the beginning of the lecture, this idea of stimulating and being able to pull from other disciplines, whether it's engineering and the sciences. Right now you have the largest growing and most inventive aspects of sciences right now are energy and human biogenetics. Like what's happening with the body and what we're doing with energy. And as an architect, we're in a unique spot because we can actually work with both. Right? So every piece of architecture is calibrated to the human body and the materials that we use to build it. So on one level you have material energies, and we just mentioned that not all of them are actually visible to the human eye. And there's a whole range of other sensory perceptions that are necessary to perceive energy. At the flip side, you have our bodies, which are changing in ways that are perceiving and advancing our senses like never before. So within our own lifetimes, the idea of going from having to wear glasses to getting contact lenses that are still an applied object, but no one sees them, to the idea of LASIK surgery, which very well could make your eyes better than they should have been when they were born. And that's where we are with the body now, is we're within our generation at a point in time where, for the longest time, it was all about making the body average. If you were born with a deficiency or you developed an ailment in your lifetime, the idea was to try to get you back to an average, so-called normal state. But within our lifetime, we're reaching a point where the question is, do we stay there or do we go beyond it? Do we give ourselves the ability to exceed beyond what we should have been born with? And I don't think it takes, the answer is going to be we're going to go beyond it. It's just in our nature. Fourth, the implications of these developments for the design profession are vast. By overcoming its continuous splintering into subsets and specializations, the now integrated fields of architecture, landscape, engineering, urban design will engage a broader directives through a new spatial material. So this is just going back to the idea in the beginning, which was by kind of thinking within this, the analogy of science fiction is most intriguing is that it doesn't ever abandon science and it doesn't abandon engineering. It just finds another mechanism to look through them and to stimulate them. It's a way of being able to paint a picture of a world that is responsible and used as a way of getting the general public to covet and want it. And when the general public wants it and covets it, that's a pressure both politically and technologically to make those advancements. And without doing that, we don't stimulate that thought. So, thank you.